This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
This week we have Michael Matias, who is at the University of California, Santa Cruz. As of recently, just moved there from Georgia Tech, where he was on the faculty. And he has, at Santa Cruz, been one of the people creating a new interdisciplinary program in game design. So they brought together people from a bunch of relevant departments, but sort of driven by computer science and by Michael's work. That's one of a new crop of game design programs that have been created around the country as that becomes a bigger part of what's going on in the computer science world. His own area of interest is sort of a fascinating cross between what people think of as game design and AI and literature. So most people who do game design think a lot about, like, beautiful textures and great rendering and speedy stuff on the screen, but not about whether what's going on is dumb to start with. And Michael and his coworkers and work that he's done, I just learned at lunch today actually that he was on the Oz project back at Carnegie a number of years ago, which some of you may have seen, the Woggles. Were they Woggles? 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 Yeah, Woggles, they were called. Yeah. Which were little creatures which were just blobs. I mean, they weren't like, Super Mario renderings or something, but had personality and character and did things. And so his interest has long been in how do you make games where the characters do things and where you have some kind of a narrative, a story cohesion. So he will be talking today about that area in general.
All right, great, thank you. Okay, so I call my sort of research agenda, research area, expressive AI. And what I mean by expressive AI is really a practice that combines AI research and an art practice. So I'm interested in designing audience experiences that are sort of deeply interactive, profoundly interactive, in a way that basically requires some form of what you would want to call understanding on the part of the machine. And I'm interested in doing AI research that's sort of driven by that art practice. So the way I like to think of it is that I'm kind of posing research questions and then hopefully answering them that wouldn't even be asked unless you were doing AI research in the context of an art practice, and being able to sort of design and build new kinds of expressive experiences that would be impossible to conceive of building unless you were doing an art practice in the context of AI research. And so I really try to have each and every one of my systems simultaneously be something that's really kind of fully produced and releasable, as shown in galleries and museums, or released as a downloadable game, or shown at media festivals, depending on the form that the piece takes, and also results in a number of both design and AI publications. So it's like each system is kind of an investigation into a series of kind of technical and design questions that also hopefully results in an interesting experience. To give a little meat on this idea of combining AI and art, because at first it might feel strange, I am not the first person to think of combining AI and art, and there's been a number of people over the years. Here's just a few examples. Harold Cohen, of course, rather famously, has been working on his painting program Aaron since 1971, and it's still kind of ongoing work. Harold left the world of kind of modernist painting in the 60s. And he was a very successful painter in England, to take on the task of basically of spending the rest of his life encoding his own kind of aesthetic and painting processes into a Lisp program, right? And in fact, he was at Stanford during the early parts of that program, kind of hung out at Sale. The Censter, around the same time as Harold was just starting his work, Ed Anatowicz in 1970 built, it's one of the earliest robotic sculptures that was shown at the Phillips Evaluon, had sort of very dynamic animal-like motions, responded to proximity and sounds generated by viewers. And in his writings, he wrote about what he called the aesthetics of behavior, and that he felt that there was a whole new kind of art discipline to be born where where the aesthetics lie not in the visuals, and not in sort of this sensory experience, but really in behavior over time. And then, of course, contemporary video games are now incorporating sort of ever more sophisticated AI models, where in the early 90s, say, game AI basically meant really simple finite state machines and kind of barely deserved the name AI for what they were doing. More contemporary games, such as Black and White, already 6 years old, are using techniques that not that many years ago were research techniques in the AI community. So in Black and White, using decision tree learning to have your sort of animal avatar in the world, you're playing God in Black and White, have your animal avatar observe your actions and learn to take actions on your behalf autonomously over time. So these are sort of three examples, from kind of pop culture and then robotic sculpture and kind of art generation that kind of represent this notion or put meat on this notion of combining AI and art. In my own work, the kind of fundamental research question is really trying to resolve the tension between autonomy and authorship. So, authors require control over an AI if they're creating an AI-based experience in order to craft the experience. The reason we go to and enjoy, a particular director's movies, or a particular playwright, or a particular novelist, right, or a particular painter. The reason we seek out those experiences is precisely because the author is skilled in creating a sort of moving and profound experience that causes us to reflect, right? And the author has made sort of, many decisions and sort of authorially directed decisions to create that expressive experience. But as soon as you start talking about interactive work, the author doesn't literally want to explicitly code everything. Right? This kind of quickly blows up into some kind of decision tree, which would be kind of the simple-minded way of thinking about building kind of an interactive system that explodes exponentially. And so you start needing some form of autonomy where the author can express their authorial intent at kind of a higher level of abstraction. And so autonomy can provide powerful emergent effects, but sort of autonomy just used willy-nilly tends to take control away from authors and can lead to generic experiences where the system just has some simple mapping rules that kind of create the same response to audience interaction over and over and over. So what we really want is some kind of AI architecture that is, or space of AI architectures that really combine authorship and autonomy, right? So these are architectures that are in a sense built to be inscribable, that have sort of the authorial affordances to allow an author to inscribe authorial intent in there, but then leverage the combinatoric power of the computer to sort of mix and match this author-created content, whatever that content happens to be, in myriad ways, while still giving the author kind of abstract control over the mixing and matching. And that is kind of a how to combine authorship and autonomy is really something that is kind of a central thrust through all of the systems that I build, and is really one of the central research questions of expressive AI. I want to sort of spend the rest of the talk kind of illustrating these ideas by talking about a couple of systems, and I'll spend a fair amount of time on one of the more recent ones, the interactive drama Façade. Façade was released. How many people here have played Façade? Has anyone played Façade? Okay. Like a few people, very few. So I'll describe it then. Façade was released a year ago in July, and it's an instance of a form called interactive drama that was, to my knowledge, first proposed kind of as a phrase anyways, interactive drama, by Brenda Laurel in her dissertation in the mid-'80s. In an interactive drama, the author, the player enters a story world that's inhabited by autonomous characters, can interact with those characters and have social interactions, and in the course of those sort of social interactions with the characters, experience a dynamically evolving story arc. So it's not sort of a typical kind of game world that's relatively flat, where there's a lot of wandering and interacting, but kind of staying sort of on the same level, without kind of any advancement. In an interactive drama, you want there to be, a clear growing, tension, a clear growing crisis, leading to a climax and some kind of resolution that involves change on the part of the characters. But of course, you don't want that story to be hardwired, but to really dynamically evolve as a function of what the player does. In the Façade storyline, the player, and I can show demos afterwards if people are interested. It's also freely downloadable at interactivestory.net. One of our goals with this research was to kind of try to get interactive drama work out of the lab and into people's hands where they could actually download it and play it, experiment with it, find where the holes are. We've had over 500,000 downloads in the last year and a sort of a fair amount of attention. So, I think on that dimension, anyways, the project succeeded in kind of at least getting the discourse around the concept of something like interactive drama into broader culture instead of it being kind of a laboratory exercise. The storyline in Façade, the player's been invited over to a couple's house for drinks, Trip and Grace. The player's told at the beginning that he or she knew them, say, 10 years ago in college, and that's it. You wander up to the door. As you come up to the door, as the experience opens, you hear this arguing behind the door. Now, it turns out, unbeknownst to the player, at least the first time they play, Grace and Tripp's marriage is in serious trouble. And in fact, tonight's the night it's going to explode. And sort of how their relationship dissolves, whether it dissolves, how they feel about each other and about you, depends on how you interact with them over the course of the evening. So imagine kind of an interactive Who's Afraid of Virginia Woolf, where the player is the visitor showing up at the door. Of course, in this case, it's one visitor instead of a couple. And Who's Afraid of Virginia Woolf was definitely an inspiration for kind of the underlying story of Façade, as well as movies like Husbands and Wives, Sex, Lies, and Videotape to a lesser extent, basically domestic dramas of that form. So what we really wanted to create, and I would claim what sort of any interactive drama wants to create, is continuous, rich, dramatic action, not wandering in some large, lushly rendered world that's punctuated with bits of story, right? But something where the kind of storiness of the experience is really happening moment by moment and is continuous. We need tightly coordinated action, canonically dialogue, where characters are actually working closely together to convey the story. So not kind of a bunch of autonomous entities that kind of trigger simple scripts but aren't really coordinating together to create a sort of total experience. We really want tight coordination in some form. We want the player to really be able to change the story, not a fixed story structure. And in fact, in Façade, you have to replay it multiple times in order to really understand the total story world, right? If you play it once, you might think, oh, it's all Grace's fault, and it's because she never gave Trip a chance, and that boyfriend she had that she actually made love to the night before Trip proposed has jinxed the whole marriage, and that's the reason why it's falling apart. And you might think that from one playthrough. Maybe you find out that particular fact, but it's a much more complex situation than that. And I kind of think of Façade as kind of this potential story space of which any one run through is kind of sampling a thread in that space, and that you have to sort of sample that space multiple times before you really understand the totality of the story. And that requires some kind of story management or story structure where the evolution of that thread depends on what you do. Finally, we want the player to be able to communicate freely. I mean, these are adult characters in a social situation, and having like sort of a few verbs where you can like run and jump and maybe shoot, for instance, is going to be inappropriate, right? So we want the player to be able to express kind of any meaning that kind of makes sense within that conflict of this sort of marital dispute. So that turns into a number of research questions then that we can start drilling down on. In this talk, I'm just going to focus on the top two, the ones in red, and sort of very briefly touch on kind of design and technology issues that are involved in solving them. But the total set of questions were really, how do you build autonomous characters? Specifically believable agents. What kinds of architectures are necessary? How do you author within that architecture? How does player interaction affect the plot? This is the problem of drama management, basically building kind of an AI director who's viewing the story world kind of from above and trying to sort of manipulate the story world in various ways that hopefully aren't visible to the player to shape the evolving story arc. Who's in control, character or story? This is an architectural issue. Most of the work that's been done in AI-based kind of interactive story research to date has focused almost exclusively either on the character side, and lots of work on different architectures for, for creating characters, or on the kind of story side and on story generation. And very few people have really tried to put those two together. And as soon as you try to put those two together, you get this kind of control contention. Should the plot be sort of driving everything and pushing the characters around? But then it's hard to get the rich, real-time emotional responsiveness out of the characters if you take that monolithic approach. But if the characters are too autonomous, then you get, sort of these emergent effects that might each effect being interesting in itself, but kind of going nowhere in terms of a story structure. So you need to, sort of resolve the architectural tension between character and story. And finally, how does the player communicate freely? This is, of course, the problem. Quickly becomes the problem of natural language understanding. If you decide you're going to let them just communicate in language instead of giving them some big, set of arcane verbs and a manual for figuring out how to use them. And with Terry here, I'll have to say a teeny bit about what we did. So obviously we didn't solve the problem, right? I mean, this AI complete problem. So the question was really, could we come up with a broad, shallow solution that worked kind of well enough for our constrained story world, and sort of, in a sense, took advantage of the affordances of our story world and kind of the way we're able to script the interactor through what's in our story world, but is broad enough to let you bring up kind of all the topics and kind of utterances that sort of make sense within a marriage falling apart, which is still a pretty broad domain, right? It's a big domain. And I can talk with people offline if they're interested in that, since I don't have slides for that in this particular talk. Briefly, we use semantic parsing to go directly from surface text to discourse acts. And we have about 30 plus parameterized discourse acts that represent things like, oppose, criticize, agree, flirt, refer to object, refer to story topic, so forth, and any one utterance is resulting in a number of discourse acts, and we kind of try to skip semantics, basically, and go right to pragmatics. And then we're doing discourse management, doing kind of the things that you would expect in a discourse manager. We're keeping track of the open conversational contexts. Each conversational context is kind of bidding for how it might want to respond and advance its particular conversational thread, given the discourse acts that have been heard, or perhaps we need to spawn a new conversational context, so forth. And I can talk more about that offline. So, drama, I mean, going back to kind of, at least Aristotelian drama and going back to Aristotle's Poetics is really the sort of plot plus characters, right? And with our kind of, computer science hat on, we of course, look at, well, plot plus character, that looks like two subsystems to me, right? And that's sort of what people have been doing since the mid-'80s and thinking about this problem, where you have some kind of AI system, often called a drama manager. Brenda Laurel called it the playwright, that's really responsible for thinking about this plot structure and thinking about this sort of this temporal structure, right? This is kind of a global temporal structure, and some different subsystem or community of subsystems that's really maintaining the character, personality, emotion, self-motivation, change, and sort of responding moment by moment to player interaction. This authorship versus autonomy problem in character AI kind of plays out in this question of scripting versus autonomy, right? And the standard approach to NPC interaction in games, in commercial games, is really a scripting approach, where you specify these kind of hard-coded small scripts that describe exactly where, how, and when characters do things. Scripts are generally triggered, and if there's a certain line a character is going to say when they're behind this desk right here, and it happens to get triggered when they're over here, then what do? They kind of robotically turn, go to the desk, kind of dock with the desk, and then deliver their thing, right? Because the script has really sort of hard-coded that exact action and utterance is tied to this specific location and is triggered kind of relatively shallowly by local trigger points. So this does, in some sense, give authors complete control. You could author just a gazillion hard-coded scripts and triggers and try to sort of populate your world with enough of those that you bring your character to life. But it's really difficult to give the character that moment-by-moment aliveness. And we've all seen that, your standard, sort of commercial game character, for example, spends most of its time in an idle loop, where they're throwing on a little purling noise to kind of, here, look, I'm alive, right? And then some kind of action gets triggered, a hard-coded script. So autonomous architectures, on the other hand, And if, looking at, say, personality modeling work that's done in the autonomous character, not autonomous character, but autonomous agent literature, autonomous architectures typically enforce a theoretical model on all character. For example, personality traits. The Big Five personality model has sort of been implemented over and over and over again in a variety of architectures. And these kind of autonomous architectures do tend to give you the moment-by-moment aliveness. The character's choosing reactions based on some kind of underlying, system, responsive system, and is able to do it, every moment, every decision cycle. But there really are no kind of authorial hooks for an author crafting specific character details in the system, right? Scripting allows you to craft these particular character details. These autonomous architectures, especially kind of personality trait-based architectures, basically require you to try and dial in a character using a small collection of floating point numbers. Introverted, extroverted, now 0.7. And you sort of try to dial in by setting 5 numbers what the personality of the character is. And as a kind of reductio ad absurdum on that idea, imagine you're trying to create, say, Bugs Bunny, the Terminator, and Hamlet, right? And you've got 5 numbers that you're going to set to differentiate them. Now, obviously, this isn't going to work. The Terminator, he seems pretty extroverted compared to Hamlet. Hamlet's pretty introverted, right? And but the details of kind of Hamletness, what makes Hamlet Hamlet, or Bugs Bunny-ness, are not going to come out of those 5 numbers. So you need some way to allow someone to get in and craft those details, something like scripting. But that then, but that gives you the moment-by-moment autonomy of these sort of character trait architectures.
So is the argument that 5 numbers isn't enough, or that this is the wrong approach?
The argument's that it's the wrong approach. I think 10,000 numbers wouldn't be enough, and would also start getting rather awkward to deal with from an authorial perspective if I gave you 10,000 numbers. But that the idea of considering considering the space of characters to be a bunch of points that you can kind of zoom in on with dimensions is the wrong way of thinking about characters. Yeah, that's the argument. So the approach we took in Façade was to create a reactive planning language called Abel, a behavior language, that's a language that sort of has custom features for supporting the authoring of characters, but is sort of rooted in this reactive planning tradition of languages like PRS, that some of you might be familiar with, HAP, which was an Oz project language. Abel is kind of HAP++, builds on HAP and extends its semantics in a number of ways. In this class of languages, the fundamental unit is a behavior. So what you're doing is you're authoring little behaviors that might be like sequential behavior open door. And this is like one way that the character knows how to open a door. And here's the steps for opening the door. And it may be doing a lot of sub-goaling. Sub-goal, the first sub-goal, find the key, right? And then there might be other behaviors, or what are ways I know for finding the keys. And so you're sort of writing a bunch of these atomic little behaviors, maybe not worrying a whole bunch about how the behaviors are interacting with each other as you author each individual one, and throwing them in a bucket. And then what the architecture should do for you, if it's sort of helpful architecture for authoring characters, is allow these behaviors to kind of mix and match richly, and for multiple behaviors to be active at the same time, and get sort of a behavior that makes sense out of the character that doesn't look like dithering or thrashing. So, for example, in Façade, Trip, likes to make these fancy drinks for the player, and there's this whole sort of, subspace of the behavior library that's all about how to make drinks and to move your hands to do that, and the sort of conversational behaviors to ask about the drink and fight with grace while asking about the drink and so forth. And then there are other behaviors that might be how to have an argument about a particular topic, like how to argue about therapy, for example. So the subject of, maybe you guys should see a counselor might come up, and so they can talk about that. Now, we don't know at design time that, Trip might be in the middle of making drinks when that topic comes up, or he might be walking across the room doing something else. So if that behavior becomes active at the same time as these other behaviors, like making a drink, they better mix together nicely. And Abel kind of gives you a framework for kind of mixing together nicely and saying, hey, how you were going to shake your fist angrily? Well, your fist actually is full with this cocktail shaker right now, so find an alternative. Oh, how about an angry eyebrow raise? Okay, well then tell the procedural animation system to generate an angry eyebrow raise while saying these lines, etc. So you get this personality-rich variation in behavior, rich behavior mixing. Can basically walk and chew gum at the same time. Language support for character coordination. So what we did in Abel was to kind of build in a theory of joint intentionality, and it's basically Cohen and Levesque's model of joint intentionality mixed in with Barbara Gross's shared plans approach, but sort of turning it into a language keyword. So what I do as a language author is if there's some goal that I want to be pursued jointly, I say joint subgoal, foo. Right? And then the system sort of automatically does what it needs behind the scenes to kind of meet the contract for a joint intention on foo at the same time that maybe a couple dozen other completely autonomous character goals might be active. So the idea was to kind of, push this dynamic slider between group mind and individual mind right into the language. So if you sort of do, use the keyword joint all the time, what you're really building is something like kind of a behavior forest, a tightly intertwined behavior forest, which is really, you could think of as sort of a single mind with multiple effectors, which are different characters. If you don't use the keyword joint ever, well, then you've got strongly autonomous characters, and there's no sort of, automatic maintenance of joint intentions. And then finally, we added meta behaviors, which so behaviors can reason about the runtime state of other behaviors, and this was powerful in allowing us to factor out canonical behavior from response to interaction. So we were able to say that, like, during this dramatic beat, here's the major dramatic goals we want to achieve in a certain sequence. And that would be the sort of the sequence of goals we'd want to achieve if there was no interaction. But of course, the whole point is there is interaction. So then you can write meta behaviors, what we called handlers, to in a sense dynamically replan the continuation of that sequence of dramatic goals in response to player interaction. So that turned out, basically, meta behaviors enabled a specific idiom that was an interesting way of factoring out sort of dramatic logic from interaction logic. So an Abel agent, sort of looks like what you might expect a reactive planning architecture to look like. There's a behavior library. An active behavior tree represents the intention structure of the agent. It's a tree, not a stack, because you have parallel behaviors. The leaves of the tree represent the things you could do next, and then each decision cycle that comes around has to pick something to do next out of the set of out of the leaves of the currently active behaviors. Just to give you some sense, like Trip and Grace and Façade are pulling somewhere between 250 and 300 decision cycles a second throughout the experience. And a lot of that is because at the lowest level, their lowest level behaviors are literally like driving the faces around. For instance, that none of that's canned animation. It's all fully procedural animation, and the system's figuring out, well, my overt emotion is happiness, but covertly I'm really upset, so I need to create a strained smile, but with this look of surprise when this certain topic gets brought up, so forth. And it's actually the kind of lowest level behaviors that are constantly kind of reasoning about that, and hence you pull a lot of decision cycles to do that. And then finally, a working memory, which sort of does what you'd expect working memories to do. Sensing we treat by basically dumping working memory elements into working memory directly in response to changes in the world. And there's sort of what we call the sensory motor abstraction right here. That is a set of kind of contracts and sort of pluggable code objects that allow you to hook Abel into any kind of real-time system. And so we've hooked Abel into like Wargus and Unreal Tournament and a number of other systems for research purposes. I'm not going to belabor the code. If someone wants to see the code in detail, we can talk about it afterwards. But just to kind of show off, look, there are behaviors. The 4 basic step types are acts, primitive acts, subgoals, and mental acts. You've got continuously monitored conditions like success tests. You've got preconditions as ways of resolving behavior conflicts when you're trying to achieve a subgoal, and so forth. So really, yes?
Those sequential behaviors look a lot like scripts.
Yeah, they do. And so, and I was saying that scripts are nice. The power scripts give you is you can really craft character details, right? So what we really want is something that lets you get in there and sort of specify the character-specific behavior for a character, but then to kind of throw it in this pool where how it gets mixed and matched with other things is dynamic. So you can think of that as kind of scripts. It's actually more expressive than what most scripting languages do because, subgoals, for example, dynamically behind behaviors, and on behavior fail, it tries to do a dynamic subgoal rebind, and, basically goals are reified. So it's keeping track of how have I tried to accomplish this subgoal so far. There's sort of success, failure, and suspension messages kind of flowing up and down that active behavior tree, and there's a lot of the language semantics is about how to sort of redirect those, because success, failure, and suspension message propagation is basically your main control logic as an author. I mean, that is how you kind of do control in Abel, is to sort of, do different things with those messages as they fly around.
Hey, Michael, can you give us an intuition as to what some of the main design goals of this language were and how it fits into the space of, like, for example, what are some properties of this that work better than Lisp, or I'm sure C is not what you want to see here. What's going on?
What works better than Lisp here is that the fundamental sort of units are behaviors, right? So which are rather than sort of functions, and you're going to sort of side effect everything from functions. What you have is sort of a pool of behaviors where the call structure that's going to exist between those behaviors sort of isn't really statically knowable at design time. So in other words, you're throwing a bunch of behaviors into a pool, and how they're going to be sort of chained together, which ones are going to be simultaneously active. You have a parallel execution semantics, which you don't have in Lisp.
Looks like you're using a sort of working memory pool, like production memory.
Yes, and it is exactly these kinds of tests, like on the success test or in the precondition. Anyone who's worked in Clips or SOAR or something is going to be familiar with those kind of tests. So it's full pattern matching. So it's you can chain bindings. The system is actually doing a lot of backtracking potentially within the test to actually find, to actually bind the whole pattern. So it's really kind of giving you a mixture of some of the features of Abel kind of feel like rule-based programming, like in Clips or SOAR or something. Some of the features feel like imperative programming, like sequential behaviors. You actually have sequentiality built in instead of having to sort of explicitly chain left and right hand sides to kind of get sequentiality, and then some of it kind of has a feel like logic languages actually. So it's sort of it's a hybrid language design. It's combining. I don't know. It's hard to sort of sit down and it's coming out of the space of reactive planning languages, which were basically invented as a means for trying to resolve the tension between planfulness, sort of planful pursuit, and real-time reactivity. And so it has those features. I mean, it does, like any reactive planning language, that's sort of what it's trying to resolve, is to give you something that looks like planful pursuit, but also be real-time reactive. As opposed to, say, like subsumption architecture, for example, which gives you lots of real-time reactivity, but you sort of have to work really hard as the author, very carefully structuring, you're very carefully structuring the sort of subsumption structure in order to get something that looks like planful activity. Here, it's kind of supposed to be directly expressible and yet also have real-time reactivity. So, some robot control architectures look like this as well. Did that help?
That was great. Thank you.
Okay. Yeah, it's always with languages. It's always, like, God, it looks like you're inventing yet another language. What's so special about this one, right? So, and HAP, the language that this language is based on, was already sort of proven successful for authoring autonomous characters in particular. And so, I mean, that part of it is I wasn't thinking from scratch about what kind of features, if I just had a completely blank slate, would I put into a language for authoring characters. It's like, well, there already exists a space of useful behaviors for thinking authoring characters. HAP, Hamsterdam, Bruce Blumberg's architecture, it looks, if you sort of squint your eyes, pretty similar to HAP. And so it's like, okay, but it's lacking certain features, so let's just build on that base and then define a language that extends the semantics in these particular ways, like meta behaviors, direct support for joint intentionality, language support for joint intentionality. There's some current research I'm doing now with Charles Isbell at Tech, which is in the same spirit of that we sort of turn joint intentionality into a keyword and just sort of pushed it into the language. We want to turn policy learning into a keyword and push it into the language. So you just author your, you're authoring your behavior library, and you happen to put the keyword adaptive in front of some of your sequential or parallel behaviors, and those become adaptation points for policy learning. It's, it's similar to, it's basically partial programming, to use Russell's terminology for it, but where Russell's kind of starting from a, he's starting kind of on a sort of theoretically firm foundation, right? That's how he operates. I do not. He's starting on this sort of theoretically firm foundation with something you can prove theorems about, and then sort of trying to grow it to a language. Like, let's take HMMs and kind of put HMMs on steroids so that you can kind of do this partial programming. I'm sort of starting with a full-blown programming language and then trying to sort of push machine learning into it. So it's kind of like we're starting from two different ends. Let me just check the time here. So to sort of conclude about, draw some conclusions about character AI, character AI of any sort should really allow authors to craft character details. And, as computer scientists, we sometimes want to kind of, run away with creating a theoretical model that captures the space of all characters in some way, right? And say, I've captured characterness and I have a theory of it and I can implement it in this code, and we've basically eliminated the need for an author. That's kind of that would be sort of, I think, a knee-jerk kind of computer science move. And it's like, no, we want the author in there. We really want languages for expressing authorial intent, not some kind of universal model of what a character is. The architecture should support combining authored character details in novel ways. So you need to be able to go in there and say, Bugs Bunny really does a double take in exactly this way, and that's part of his Bugs Bunny-ness. And it would be really hard to sort of derive that from some kind of first principles from a character theory, that's how Bugs Bunny is going to do a double take. So I better be able to kind of stick that in there somewhere, but then have that sort of recombine in interesting ways with all kinds of other details I've kind of thrown in the pool. The system should support simple and complex characters in sort of a scalable way, instead of having to swallow this huge lump of complexity, regardless of how big or small your character is. You'd really like it that a really simple character is really simple to author in the architecture, and a complex one is big. And so we have simple characters that play tag in Unreal Tournament, these little child characters that play tag, and they're like a page of Abel code, kind of what you'd expect. Trip and Grace are like 250,000 lines of Abel code. So they're, complex characters are complex, simple ones are simple, and you don't want just some kind of uniform, complex, large complexity threshold that has to be swallowed before you get anything off the ground. And I find that trait and emotion frameworks can be useful, but they should support authoring and be capable of being overridden. So if you're using an OCC model of emotion, which is basically cognitive appraisal models of emotion, for those familiar with cognitive appraisal theory, are the most common models of emotion used in character architectures. But my approach to, say, OCC or its variants, or Tony Clark-Courtney appraisal theory, is that you should be able to author custom emotions, right, within it. And it should really be, I really kind of view emotion frameworks as basically bookkeeping systems that do some bookkeeping, state bookkeeping for you, that's useful for modulating behavioral expression. And not that it's some kind of, sort of all characters must have these 7 emotions and only these 7 emotions, because that's what our emotion theory says they have. Again, the whole point is expression, not sort of the clean model of all of human behavior or something. All right, shifting gears to story AI. So we talked about Façade also has sort of this drama manager. And any work in interactive drama is going to be concerned with trying to build kind of an AI-based story manager or drama manager. The big enemy for story AI is the story graph, right? Where you have nodes that correspond to units of storyness, whether those are cutscenes or little interactive moments where you're running around for 5 minutes accomplishing a goal, or a page of text if it's a hypertext system. All of those systems have the flavor of, okay, the nodes of storyness are explicitly laid out, have been authored. All the links between them, these are, depending on how the player, what they do in each node, there's this sort of small set of links that tell you exactly which node you're going to go to next, and that's your sort of interactive story. It's basically choose your own adventure, and then sort of choose your own adventure on steroids is what, sort of most kind of game approaches to interactive story are. So you certainly have authorial control. Now that's true, because all possible paths have been laid out explicitly. But The fact that all possible paths must be pre-coded by the author means that in practice, not in principle, but in practice, you can only make very small stories. This blows up on you exponentially, and what people end up doing in practice is to have a single backbone, basically a linear story with sort of branches that fold back in. Sort of fold-in branches on a single story. It's sometimes called a quasi-linear structure. And the reason they do that is because if you try to do something sort of more ambitious, you quickly find yourself in kind of an exponential blow-up as the author. And bits of story can't be incrementally added. If you did decide to be really ambitious and had a story graph with 500 nodes and a couple of thousand links, and late in the design process you decided, oh, here's another bit of story, another scene or beat, say, that I'd like to drop into the system. Let me just drop it in. Well, guess what? You're probably going to spend a long time actually reworking the graph structure so that new story piece kind of fits in. So the way I kind of think of drama management at the sort of research agenda level is that what we want to do is replace the story graph with something that looks like this, where you take the nodes, and instead of the author sort of manually hooking together all the nodes, whatever the units are of the story, they're kind of plopped in the story library. You then author some kind of selection policy, which includes within the selection policy a model of what constitutes a good story in this particular story domain. And then you look at the partial history of the story so far, which includes, of course, all the player interaction as well. And based on that partial history so far and this model of story that's kind of implicit or explicit in the story policy, selects the next bit of story to happen, right? Now, if I ran all partial histories through this thing and kind of recorded what the system did as in response to each subsegment of all partial histories, I could recover this graph. But the point is that the graph's been left because, of course, any computation can be looked at as a state transition graph, right? And so certainly story management can. But the difference is that instead of the author manually unwinding the state transition graph, the story graph, it's been left implicit, and you let the system unwind the graph. So that's really what a drama manager is doing for you. That's the sort of power it's giving you, is to not force you to, as the human being, to do all the unwinding to produce this thing. It does require that you have some way of specifying this. But so presumably, in order for this to be a win, specifying this has to be simpler than just writing all this out. To actually, instantiate that sort of abstract, architecture schema, I guess, into a specific architecture, a specific drama manager, you have to answer a number of questions. And the design space basically looks like this. What are the story moves? Those nodes. What are they? What kind of grain scale are they? What kind of content's inside them? Is it content that's opaque to the system, to the computational system, like a video clip, or is it content that's transparent to the computational system, like some kind of declarative representation? How is the desired story represented? What's the selection policy, and when does selection happen? For Façade, in the beat-based drama manager, here are the answers to those questions, and then I'll sort of walk through it in a teeny bit more detail. The story moves are dramatic beats, and I'll talk in a second about what dramatic beats are. But it's a term from the theory of dramatic writing. So if you pick up any kind of how to write a award-winning screenplay book or something, you'll see it talk about dramatic beats. How is the desired story represented? It's represented as declarative selection knowledge on the beats and procedural performance knowledge coupled with each beat. What is the selection policy? Well, the policy is to maintain a probability distribution over potential next beats. And I'll talk about that in a moment. When does selection happen? When a beat completes or aborts. So you're sort of within a beat, you get to the end of that beat, and then at that point the drama manager's drawn some kind of probability distribution over next potential beats. You draw from that distribution, that's the next one that's going to happen. So what is a dramatic beat? It's the smallest unit of value change in a story, in a sort of dramatic, in an enacted story. Another way of thinking about that is it's the smallest bit of sort of coordinated action which moves the story forward. So story values, when screenwriters or playwrights talk about story values, they mean things like anger, love, trust, hate, tension. These values that are either kind of describing the state of individual characters or relationships between characters. So they're properties of characters and relationships. And so you can imagine, a particular beat, like a certain action-reaction pair in dialogue. that would constitute kind of the smallest beat, is generally sort of canonically an action-reaction pair. Character A says something, character B responds, and in that sort of statement and response, the love between the two characters has been ratcheted up a teeny bit, or ratcheted down a teeny bit, or the anger has been ratcheted up, so forth. Activity without value change is not dramatic action. And so if you've got some action or activity on screen where cars are leaping off of bridges and things are exploding and buildings are falling and all kinds of sort of exciting kind of visual activities happening, but it's not changing story values, then it's not considered dramatic action. It's considered activity. And you can think of the goal of a beat-based drama manager would be to try to turn as much of the activity that's happening in the story world into action as possible, right? To have as little sort of to have as little kind of noise in the sense of just like, yeah, things are happening, but it's not adding up to anything as possible. So what we did is we said, hey, you read some of these how-to books on story, like McKee's book Story. I don't know if any of you have seen that. It was kind of poked. Gentle fun was poked at it in the movie adaptation. If any of you saw adaptation, the guru, the screenwriting guru in adaptation, that was actually McKee, and his book Story that sort of Nicolas Cage's twin was really into. Well, that's we read that book, and the nice thing about these sort of how-to guides is they really try to be reductive about what makes a screenplay work, which actually provides a lot of interesting architectural guidance when you're building a computational system. And so we kind of read, as we were reading the concept of beats, it's like, hey, we could turn that into a unit, into a unit of knowledge representation. It's sort of similar to a plan operator. Your effects would be changing a story value. It doesn't have something as simple as just a precondition. There are other things that kind of condition when it's selected, but it's sort of vaguely reminiscent of a plan operator, a strips-like plan operator. So within Façade, beats became architectural entities that combine sort of the declarative knowledge to sequence beats, the procedural knowledge to coordinate characters, and they also became kind of the unit of meaningful player interaction at the story level. So, for example, we might have a beat in the system. We do have a beat, introduce Grace's buried desire to be an artist, who might have a precondition saying the story has attention level 1, and we're after the greeting, and the affinity is neutral. Then in this condition, this beat could potentially happen, right? And then it turns out there's all kinds of other conditions, sort of declaratively represented conditions on the beat that condition its probability, make it a lot more likely or a lot less likely, or boost it into a different priority tier. And those are sort of other additional levels of control you need as an author. But at the most basic level, it's just like, when is a beat even possible? And the preconditions kind of capturing that. And then tied to that are sort of some beat-specific behaviors that are kind of going to be dumped into a character's mind on top of their more sort of general behavior library for how to carry out the activity of this beat, the action of this beat. So Grace, at a high level, Grace is going to complain about her decorating. Trip insists it looks great, and they force the player to take a side. And and why are these behaviors? Well, of course, this might be 45, 50 seconds of screen action in Façade, and there could be lots of player interaction during that screen action, right? So you actually need sort of a behavior space that's going to be trying to carry out these dramatic goals while responding to the player, and might be having to mix in other topics, find alternative ways to express these, to actually express these goals, and so forth. So this can't be sort of a, just like a canned kind of cutscene or canned script kind of thing. It actually has to be sort of a space of behaviors that can respond dynamically while trying to carry out a sequence of dramatic goals. Yeah?
How procedural is the character's dialogue? Is that drawing from a list of 2,000 lines?
Yeah, the final, we're not doing natural language generation. So we have, it's something on the order of like 9,000 lines of dialogue and phrases. We do some phrase level concatenation, not too much, because anyone, if you concatenative speech synthesis is all about how do you do that at a fine grain size. And so, of course, when you just start throwing phrases together, you get all kinds of crappy audio effects. But we do a little bit of it and kind of did as much matching as we could to make it sound good. But yeah, so there's really ultimately like 9,000 pieces of content that are ultimately being sort of chosen from by behaviors, right? Or another way of saying it would be sort of lines or phrases from that content are kind of wrapped within behaviors that are also kind of dramatically performing that line, right? So the character, there's lots of ways the same line can be performed, for instance. And yeah, NLG, that ultimately limits our generativity at the story level. And we just sealed off NLG because for a couple of reasons. One, we're biting off enough hard problems in one project. So that's a pragmatic reason. Practical reason, and another that's kind of a practical reason as well is the current state of speech synthesis. If we did generate, unless we're going to throw up text balloons, which we could do, actually for most of the project while we were working on it, it was like a 5-year project, and for most of those 5 years, we were watching text balloons on screen that they speak, because you don't want to do all the effort of, finally committing to dialogue until you're done, basically, to the final dialogue. So we could have either shipped as text balloons or tried to use speech synthesis, but even the best sort of, the state-of-the-art speech synthesis sounds pretty natural now for affectless flat speech. Which isn't dramatic dialogue. And so what you really need is sort of pragmatic variation, sort of control over pragmatic variation on the utterance, on the actual speech utterance, so that you can be, really excited and angry, or kind of soft and sad, and nobody's got that.
Same set of words with multiple affects.
Yeah, we do. Yeah. So that was, for the speech, for the voice actors, there was like, many days of sort of saying some of the same words and phrases at, different affects and so forth. And of course, a lot of because humans, voice actors are good, if you get good ones, there's a lot of character interpretation that's going to be read into the characters on the part of the player that you're getting just from the way that the speech is delivered, the lines are delivered. And if I was going to use voice synthesis, I would want that level of control over it, and it just doesn't exist now. So I do want to get into NLG. There's actually been very little work in pragmatic variation in natural language generation. I mean, there's like Hovey's dissertation, and then you start scratching your head to think of others that have really played with pragmatic variation. And it's kind of too bad that area, there's not a lot of work in it. That's Charles Calloway, who's a James Lester student, was doing some work in dialogue generation within story generation. That's another one, but there's not very much.
What percentage of the 9,000 lines is exposed in an average execution?
We're about, this is very rough, but we like to think of it as about 1/5 of the contents exposed in any one execution. Because we were shooting for being able to replay it about 5 times. It doesn't mean, obviously, that between different executions you're going to get exactly disjoint thing. I mean, it's not, it's not going to happen that way. But we kind of feel like if you play it, well, it depends on if you have successful interactions with it. About 5 successful interactions, you will sort of have a pretty good idea of the space. Some players, there are, sort of Façade fans, I guess, out there who play it dozens of times, right? And I've even talked to people who have played it dozens of times and never actually gotten to the end of the story. They always get thrown out first. And so I ask them, well, what kind of final endings have you seen? And, I always get kicked out. It's great, And it's like, which is what happens if you do sort of 3 completely socially inappropriate things in the course of the story. You just come in and start like swearing at them and sexually propositioning the characters and all that. They get really shocked and upset, and we've got some funny sort of shocked behaviors that we've got in there. But after 3 times of that, Tripp's just like, I don't know what got into you tonight, but you have to leave, and physically grabs hold of your viewpoint and throws you out the door. So, because of course a lot of what players do, a lot of the game playing, when you first play a game, is about finding the edges of the experience, right? And so we knew we wanted to support finding the edge of the experience and make it sort of in a sense pleasurable to explore the edge, which in Façade, the edge, rather than being like the physical edge of the world or something, it's sort of the edge of the behavior space. And we wanted to make that enjoyable, but also communicate that this might not be, the most effective way for eliciting behavior from the system. Like that there's more behavior to elicit that you can't elicit this way. And so this sort of, 3 tries, you're out, but with lots of entertaining sort of shocked dialogue that happens along the way was our solution to that, to kind of design solution to that. I'm going to try to wrap up in like 5 minutes. This goes till 2, right? And we want to have like a good chunk. Okay, perfect. So another approach to drama management, another way of sort of cashing out that architecture schema that I put up on the slides, is this search-based approach that was first explored by Peter Weyrock and that we've been exploring in my group, kind of building on for a while. Not using the search-based formulation, but it's a nice way of thinking about the approach. So in the search-based formulation of drama management, what you give the system are a collection of plot points, which are sort of significant moments in the story. I learned a particular fact from a character, or I killed the villain, right? That would obviously be a significant plot point. So you've got a set of those. You've got a set of story moves, which are ways that the drama manager has available for sort of warping the world. Like physically move the safe from room 1 to room 2, assuming that the player hasn't explored room 1 yet. So they never knew the safe was there, and it turns out it would be more convenient if they found it now instead of later, more convenient in the sense of making a more interesting story structure, so physically move the safe. And that kind of physical prop manipulation would be an example of story moves. The other, sort of obvious category is giving autonomous characters goals. Go and tell the player this. Sort of stand around on this street corner so you can be bumped into pretty easily, because we want, that having this interaction happen next would be good for the story structure, so forth. So you got a set of these moves for sort of warping the story world around the player. And you have an evaluation function over here, sort of a story goodness function that given, and the story goodness function is not universal. I'm not saying this is some universal theory of what makes a good story, but is a particularly authored function that for this particular story world captures the author's aesthetic of what constitutes a good story. And what the evaluation function is given is a total order of plot points, right? So the story is being captured kind of at the abstraction level of plot points. So there might be like 10 minutes of activity in the world, sort of in a sense within a plot point to actually accomplish it, but we're going to model it at the level of these plot points. So I give this total order, evaluation function spits out, that story was a 7 on a 1 to 10 scale. So then, of course, what we want to do now is if you have a partial history, some player made a plot point happen, system warped the world in some way, player made another plot point happen. Should I warp the world now or not? Always like the null actions, always available, right? So out of all the ways I could warp the world as the drama manager, including not doing anything, which should I do now to maximize my sort of expected story goodness? But all I have is an evaluation function that operates on total orders. What do I do? Well, this is chess, right? So what I do is I imagine warping the world in all possible ways, all possible plot points the player could do after each of those drama manager moves, which are, presumably that probability distributions have been conditioned on what the drama manager move does to the world, etc. Out to the end. Now I have a huge number, sort of an exponential number of total orders, feed them in, back the values back up, but I don't minimax, I expect a max, because you presume the player is not trying to make the crappiest story happen possible. It's more that they sort of don't know that there is a story to happen. They're just sort of reacting in the world, and a really sort of zeroth order way of modeling that is to say, okay, what they're doing, they're sort of using a flat distribution for deciding what they're going to do next. So you kind of expect to max it back up, and now you've got values on your drama manager moves, and you do the one that has the highest rating. So it becomes this kind of, it's this way of casting drama management as this funny asymmetric game where the two players have completely different moves. Player can make sort of significant story events happen. A system can warp the story world around them. And it's not quite an adversarial game, so it's this strange kind of non-adversarial asymmetric game, but you can cast it as this kind of problem.
Can you use history of multiple people playing the game to assign probabilities to those that are better than uniform?
Yes, and that would be, we haven't done that, but yeah, that's a good, that is something we've been thinking of doing. You have to have sort of enough playthroughs to, you need a pretty large sample,
when
which
people
is...
download those 500,000 downloads, do you get information back?
No,
right?
we don't, which would be nice. We've asked for, we have at various points solicited people to send us their play logs. So we do produce play logs. It's not the full AI. I mean, there's also an AI log that's kind of produced behind the scenes, but you have to hold down a special key to get that. But the system does expose to the player the screenplay, where it sort of produces as a screenplay, trip, grace, player, what they said, and you get this sort of generated screenplay. And people actually like swap screenplays on the web, and there's blog post sites where people post the screenplays they did where like, hey, I went in and pretended to be a zombie and just said brains over and over through the whole thing, and here's what happened, right? And so it kind of becomes this, and I mean, that's why we put it in there, because we're hoping to get this kind of sort of collector mechanic going where people would want to like exchange these things and stuff. But we have asked people to to send those to us, and we haven't been that successful. We have, maybe 500 or something, so not tens of thousands. It's too bad. But yeah, that would be a great way of tuning these distributions. Now, this is not tractable in real time, doing that kind of search, obviously. I'll talk in a moment about what we've been doing to try to resolve that. But first, the evaluation function. It sounds kind of mysterious, like story goodness. What does that mean? Well, it's actually kind of a pretty dumb model that we're using right now. It's a linear combination of features, where our features, what we're trying to do is kind of come up with a library of features that might be generically useful to authors, and then they're going to have to probably author a couple of specific features for their particular story world, but we hope that there's some general ones that they can just kind of pop in. And our features are things like activity flow. All things being equal, prefer consecutive plot points in the same place. And as long as you've sort of just marked on your plot points where they physically occur in the world, that's really easy to evaluate, just to score, hey, this happened, these 3 plot points happen in the same place consecutively. Or all things being equal, prefer consecutive plot points in the service of the same player goal. Or all things being equal, prefer the player to have more choices earlier on than later on. And this is sort of, Aristotle talked about this sort of flying wedge model where where dramatic possibility is supposed to narrow down into kind of dramatic necessity. And so there's this sense of like anything could happen at the beginning, and then that becomes sort of narrower and narrower until by the end, the one thing that the only thing that can happen is what happens, right? And so that's sort of this, because there was this notion of fate, of course, in the poetics. But this becomes this has sort of been adopted even into sort of present-day Aristotelian storytelling, like Hollywood movies, into this notion of this kind of flying wedge, dramatic possibility narrowing down. So we capture that in a sort of simplistic way with this choices measure. Now, the nice thing, what the drama manager is giving you basically, is it's easy to think of these features in this sort of all things being equal way. Resolving the trade-offs between them is sort of hard. Like if I had to explicitly write trigger conditions, for example, that resolve the trade-offs, that would be hard to do as an author. Using this sort of search-based, or as we'll see in a moment, optimization-based formulation, you let the system resolve the trade-offs. So it could be that, well, if we have these 3 plot points happen in a row, in this one location, that would make activity flow higher, but it's actually going to kind of mess up goal flow. But it's pretty good for choices, and how do you resolve that? Well, it just kind of falls out of the mix. And so it sort of allows the author to think in this sort of decomposed way about the features of the story, and then have the drama manager figure out how those decomposed pieces, contribute to overall story goodness. I'll just say very briefly describe optimization-based drama management. Basically recast search as policy, offline policy learning. We started actually with, of course, the obvious place to go is TD learning. And Tesaro rather famously built a master-level backgammon player using temporal difference learning offline to learn sort of a static policy. Represented his particular function approximator happened to be a neural net, but it could have been any function approximator. We've played with neural nets, we've played with Canova vectors. And actually now we're doing something rather different, but I'm not going to talk about that here. But it's also a form of offline learning, but we've kind of moved away from TD learning. But the general lesson is kind of to say that, hey, well, if you cast the problem as this sort of game tree search problem, you can trade doing a lot of offline computation to basically learn an online policy that's doing the equivalent of that search relatively instantaneously online. And we've been pretty successful with that. I can talk more about that with people later if they're interested. Doing some drama management work in Neverwinter Nights right now. So a lot of, I don't know if anyone here is doing kind of game-related research, but in the sort of community of people doing game AI research, academic game AI research, Neverwinter Nights is is sort of like the white rat for sort of story-based AI, because it's, it gives you kind of a nice, easily modelable framework for that. And then Unreal Tournament has become kind of the white rat for character AI. And I also do a lot of Unreal Tournament work. And the idea behind using these commercial game engines is just that you get some production values, you get a lot of the sort of graphics problems that you're not interested in dealing with as an AI person solved for you, and like any sort of contemporary game engine, they're highly moddable. They're giving you all kinds of scripting layers, as well as usually a sockets layer that lets you hook external AIs into them. In Neverwinter Nights' case, actually, there was sort of a big hack someone had to do. In Neverwinter Nights runs in a sandbox, and someone found a way of hacking the sandbox to get sockets into it. And so people use that mod. The next direction I really want to go with sort of drama management, however, is in a sense, all the drama management work I've been describing is taking this story arc, story graph, and making the links virtual. Right? Sort of removing the links, making them virtual and kind of filled in dynamically by the drama manager. The next move is obviously towards story generation, where you make the nodes virtual. And I've done some work in story generation in the past, a system called Terminal Time that generates ideologically biased documentary histories in response to audience feedback, and has like, a big symbolic model of ideologically biased reasoning, a symbolic model of rhetoric, and a symbolic model of sort of historical storytelling of the sort of Ken Burns style documentary, where you kind of shape history onto an Aristotelian story arc. There's got to be villains, there's got to be heroes, there's got to be a clear crisis, and so on, rather than just sort of the bunch of noise in a sense that history really is. And so this was work that kind of drew on, it actually draws on most heavily on a model of ideologically biased reasoning that Jaime Carbonell explored in a system called Politics. But it sort of extends politics in a bunch of interesting ways to sort of turn it from an interpretive system into a generative system. I've got rhetorical goals I'm pursuing. How do I accomplish those goals in the service of this ideological position? Terminal Time was sort of, I guess I would call it sporadically interactive. It was sort of an audience, a mass audience kind of interactive cinema piece where you would be asked to, you'd be sort of target marketed with a series of these questions, kind of sussing out your ideology, like, which of these phrases do you think best describes you? A, things were better in the time of my ancestors. People hoot and holler, and applause meter measures how loud people clap. B, things are good and they keep getting better every day. Or more provocatively later on, which of these phrases best describes you? A, it is okay for two men to kiss in public. B, it is not okay for two men to kiss in public. Hoot and holler, and of course we're playing with sort of public performance of one's beliefs, obviously, with the question choices. But those questions get asked 3 times during the experience. Then the system goes away after each set of questions, thinks for a few minutes, and then starts projecting the generated documentary, where it selected the video clips and generated the narrative track, which we are using speech synthesis. We do NLG in this one. And so forth, and that plays for 6 minutes, and then there's more interaction and so forth. The question is now, can you do something like this much more generative story model in a kind of real-time interactive way, in a system where there's continuous moment-by-moment interaction, not sort of this punctuated interaction? I want to end by briefly, so I'm doing work with Abel and Unreal Tournament in and my hope is to release Abel UT, the Abel UT framework, for sort of publicly for researchers and other people to play with. We've built this sort of office politics world called .com, which is a full conversion mod of UT that we kind of use as our test bed. So if anyone's seen like The Office, that BBC sitcom, just sort of picture like if The Office was an interactive drama, right? That's kind of the .com world. I'm also doing some work just to give a flavor of some of the work I do that's not really game related. Obviously, Terminal Time isn't really game related, but it is expressive AI. I've got a current project in an area that I call Alien Presence, which is basically about building ambient systems that offer participants opportunities to reflect on their own kind of day-to-day experience by making it strange. Right, by sort of, in a sense, interpreting their own, their day-to-day experience in this alien way, in this non-anthropomorphic way, and then reflecting it back in an ambient display. So this is sort of exploring at a high level the notion that, wow, we spend a lot of time in AI building systems that sort of model or mimic various forms of kind of human perception and human understanding, but there's all kinds of other intelligences sort of waiting to be born that aren't human at all. So why not create some of those?
Can you just give a little more concrete example of what that does and what it looks like?
Yeah, so I'm going to jump through here. So the first one, Office Plant number 1, which was built in the sort of late 80s, was a desktop robot that responds to the social and emotional tone of the email you receive. So it's sitting on your desk, very slow ambient movements, gentle waving of fronds, different pattern, shape memory alloy actuated, various kind of ambient sounds made by the speaker in the bulb, so forth. we sort incoming email into social and emotional categories using statistical text classification techniques, except unlike most statistical text classification that does content classification, we're doing kind of a form of tone classification, right? Which there's been some work on, but not nearly as much as like the Reuters news categories or something. Corn, I've detected this as a corn story. This is more saying, can I detect that this is a chatty email, an intimate email, a request, a response, a social invitation, so forth. Those are the kind of categories. Those then drove behavior, but not in a simple one-to-one way. And this is where the sort of kind of alien response to it comes from. Is the sort of anthropomorphic thing to do would be you get a happy email and ooh, the plant's happy and it blooms, and a sad email and it goes down, and you've basically built kind of a robotic Biff for your email, right? Which would not be very interesting, or I don't think would be very interesting. So instead, office plant number 1 had sort of its own long-term behavior. And there was sort of a recurrent neural net structure with a winner-take-all policy between the nodes, where each node is sort of representing behavior that could be active. And because it's a recurrent net, of course, you're stateful. And so what you're really doing is sort of you're able to carve arbitrary dynamic systems, including sort of chaotic systems and systems with long transients that go to an attractor and so on, using, by sort of tuning the weights of that network. And actually Bart Kosko, fuzzy cognitive maps in the sort of, fuzzy literature are essentially recurrent neural nets, and he actually kind of proved the theorem showing that you could model arbitrary dynamical systems with such a recurrent structure. So we've got this dynamical system that's kind of kicking around, doing its thing. The plant's got its internal life, but then we're dumping activation energy as a function of the categories into nodes in this network. And so what the mail's doing is as it's received and kind of interpreted, is really sort of kicking the plant around in this behavior space that is history dependent, and thus kind of context dependent to what's been going on in your particular kind of office day, right? Given the email stream you've been getting. And so the idea was that if you live with the plant long term, you start being able to kind of build stories and interpretations about the relationships between the plant's behavior and your email stream, but not these sort of simple one-to-one transparently learnable mappings. So this is really exploring the idea of ambiguity being a good thing in design. And what we're really interested in is this sort of what we call, and this is some of this theoretical work is based on lots of discussions with like Phoebe Sangers and Bill Gaver and Kia Hook. We've sort of formed something we call the Affective Presence Consortium, which is our which just means like a group of people who talk about this stuff and then try to find funding to support each other doing this. But in this group, we often talk about this notion of co-interpretation, where the system is doing some kind of active interpretation, and I'm sort of the most kind of AI-heavy member of this little community. So I'm interested in that box up there being pretty big, sort of interesting things happening up in that box, but not necessarily trying to go for human interpretation. But you've got active system interpretation, and it's generating the display, but then you've got the participant also interpreting the display, and the display becomes a site for co-interpretation. But so the system's doing interpreting, the human's doing interpreting, as opposed to like a lot of like information art kind of work that really goes for these one-to-one sort of decodable displays. Like if I know how stocks prices map onto the color of sails in this little like sailing picture or something, I can like look at the display and go, looks like the Dow's up 5 points today because the sailboat's over to the right and its sail is red, for instance. And they really, information art really seeks to basically create decodable displays, where this work is like, no, we want to create sort of a site for interpretation where you've got the alien and you've got the human, and they're both sort of working together in a sense to make sense of the display. The current work in this space is Tableau Machine, which is a background presence reflecting the mood of the home, and it's basically an art generator. So we've got this art generator hanging on the wall of the living room. It's generating here some sort of sample output from the art generator. It looks an awful lot like sort of like Composition 101, kind of sort of compositional exercises, basically. So it's sort of, that's sort of its level of sophistication of creating compositions, or these sort of abstract machinic compositions. And we're sort of riffing on the idea that Corbusier quote, a home is a machine for living in, which was kind of this, sort of high modernist statement about the home. But the part that really interests us is is to sort of, in a sense, if you start taking that literally at face value and asking, well, what kind of a machine is a home? What if your home was sort of a machine, and what would it generate? What would it look like? What would it live on? And so we're kind of riffing on that and thinking about this piece, and that's why we chose this machinic composition space for the system. But unlike most generative art that's been done to date, this system has eyes instead of it just sort of generating in a vacuum. In a sense, a lot of random number generator filtering through some architecture and leading to the generation of some final visual display. Here, instead of a random number generators being the sort of energy source, at the bottom of the system, it's interpretation of home activity. And we're using cameras positioned throughout the home to sense physical activity in salient zones. And so we have, as humans, kind of zoned off the home into what we call semantic activity zones, which was based mostly based on kind of ethnographic work done in the Aware Home at Georgia Tech, which is this sort of platform for ubiquitous computing in the home research. So we have sort of, the sensing in the home. We can pull sort of motion activity that the camera system picks up, and I can talk about this with people offline if they're interested, but the sort of high-level interpretation we give on that are what we call social energy, social density, and social flow. So we have this sense of, sort of how are lots of people together, or are they tending to be dispersed through the house? Are people sort of really active right now, or are they kind of quiet? Are there like large groups of people kind of being quiet together, large groups of people being active together? Is there a lot of movement through the home with sort of movement back and forth across sort of these salient zones, or is flow relatively small in the home right now? Then that basically is modulating a rule-based system that finally generates the display. And so it's sort of like having this, living artwork on your house, on your living room, that sort of, as every time you look at it, that somehow is a reflection of what's currently going on in your home. And in fact, kind of offering you that opportunity as a person living in the home to kind of question and say, well, why is it doing that right now? Let me stop and think for a second, what's going on in my home? That's kind of what we're going after. Again, this idea of offering participants an opportunity to reflect by rendering their own daily activity as strange. This kind of move of making strange, which is, in a sense, the fundamental, kind of ethnographic move, is to kind of make strange daily activity. And with that, I think I'll end. Thanks.
Questions? How do you envision next interaction material actually obviously, just be
I'm thinking a lot about authorship these days and how to, right now Façade, creating something like Façade is still a lot of work and basically requires you to be both sort of a story author and someone who knows a fair amount about AI. Because to author in languages like Abel, Abel's got parallelism built in with all the sort of hairiness that parallelism can result in. It sort of assumes a familiarity with knowledge representation techniques, so that sort of all this matching over working memory that you're doing, realizing, hey, that's not an if statement, right? And that's when I've been teaching sort of new people how to use Abel, really conveying that this is not an if statement, it's something more, is always a challenge. So obviously Abel's kind of the wrong level. The thing that's hard here, though, is I do believe that authoring interactive stories will fundamentally require procedural competency, procedural literacy. Like, I don't believe that there'll ever be some kind of like GUI thing where you just poke and prod at a few buttons and slide a few sliders and voila, some interactive story comes out. This is fundamentally a procedural medium, and authors will need to sort of, in a sense, think like programmers, but I don't even like saying think like programmers. It's more think procedurally. Be able to think in terms of processes as opposed to in terms of kind of static representations. Now, I think those processes can be expressed at much higher levels of abstraction than we're currently expressing them, and I'm interested in going after that. But I think any attempt to completely hide the sort of process nature of the authoring and turn it into effectively the selection of parameters of various kinds, both numeric and symbolic parameters, by pulling down and monkeying around with a GUI, for example, all that's going to do is basically the author of that authoring system will have reified some particular space of stories and then sort of made that space of stories accessible by how you select these parameters. So you wouldn't really be able to be a general author in a sense. You would be basically playing around in this rather constrained space that the tool author's given you. And in fact, you would probably find it confusing, the relationship between the selection of these parameters and the final interactive story that's generated, because there would actually be, those static parameters are going to get turned into some kind of process to actually give you the interactive story. And if you don't have sort of a procedural literacy to kind of think about process, it's going to be this sort of mysterious authoring step of like, oh, I selected these numbers and I pushed the button. I wonder why the characters are acting this way. So I don't believe in like shielding authors from and shielding artists from procedurality, but sort of finding ways to tailor procedurality to the expressive form. So like when I was at Tech, one of the classes I taught I was in two departments there, literature, communication, and culture, and then the College of Computing. And in my LCC teaching, one of the courses I developed there was a master's course called Computation as an Expressive Medium, which was specifically kind of a graduate level introduction to programming and computer science for artists and humanists. And the idea behind the course was not sort of dumbed down computer science, not by a long shot, but more like what would computer science look like if sort of artistic expression and authorial expression were what it was considered to be about from day one. It wasn't about sorting lists and learning algorithms for this and that. It was like about expression. And we sort of thought in terms of kind of the authorial affordances and interpretive affordances of computational of computation from the beginning. What would CS look like? And so that was my sort of in a sense, the whole course was like a thought experiment for me as well as a class for the students. But that was sort of like, I was eating my own dog food in the sense I was saying, if I really believe that sort of artists and humanists should be procedurally literate and that they, then there, darn well better be a way to talk about computing in those terms and to sort of rethink computing in those terms. Yeah.
So could you go back to I think it was your first slide with the circle?
Yeah.
The AI on one side and art on the other side.
Yeah.
And I'm wondering. So I'll share with you a challenge that I have, which I think is analogous to the challenge here, is that my two goals or metrics for success are, on one hand, I hold myself to user-centered design, and on another, to doing research. And doing good user-centered design doesn't necessarily yield good research out the other side. They're not in conflict with each other, but it may be, that the best interface for UC Santa Cruz professors is not anything novel, and so that great user-centered design might not be anything novel, and I wonder, and sometimes you get lucky and it's this beautiful confluence, but and so I was wondering if you could just share your thoughts on, for you, do these things, how easy is it for these things to be synergistic, or sometimes are they at loggerheads?
So the nice thing about sort of having a studio practice is that you do get to sort of conceive of the project independent of, say, a user base. In this case, like I don't have to, like I tend to just naturally gravitate towards, like sort of when my conceptual work, basically, when I'm sort of, coming up with project ideas and so forth, I tend to naturally gravitate towards things that just inevitably have really hairy AI research problems tied up in them. And that's partly just because I do, in some ways, kind of my secret agenda here is I do think expressive AI is actually kind of a secret backdoor towards the original AI dream. That this like frontal assault approach of like, today we have theory proving, tomorrow the world, or something that's sort of been the history of AI. That, what people have actually really wanted from the beginning was to build these others, to build kind of people, but not even, sort of like generic people, but specific, like Woody Bledsoe's speech at I think it was a 1985 AAAI conference. He was the president, and he talked about dreaming from the beginning of creating artificial people who, and his dream artificial person liked to play games and ping pong, especially with him, right? And like to, and so it was sort of I think the AI dream has not been about building this sort of, generic rational intelligence, but about building these others, that by interacting with these others we learn something about ourselves, these kind of liminal others. And artists know how to create sort of rich experiences that support reflection, and in fact rich experiences of the other. Character artists, for instance. Character artists have been a heck of a lot more successful in bringing characters to life than like AI has been so far in bringing characters to life. So why not sort of put the two together and kind of sneak up on AI from the back door instead of this frontal assault, and say, hey, let's take expression as the first class goal, and guess what? As you ratchet around this loop, you'll end up, you'll be moving closer and closer to actually fulfilling the real secret AI dream, the thing that got people into AI, HAL 9000, right? Or more recently, data. Right, that's what's getting people into AI, and then somehow, once they actually get into it, it's like, no, what I'm really interested in is proving theorems about these support vector machines. But no, I mean, they're interested in HAL 9000 and data, but somehow you don't get to talk about it. So this is a way for me, in a sense, I get to do that as like my first class activity, and and generate artifacts that actually have cultural relevance along the way. So that's another problem with sort of the frontal assault approach to AI research, is the incremental artifacts you produce along the way just don't have much, cultural currency, right? Where, something like Façade, or Terminal Time, or, any sort of contemporary game that's using kind of heavy AI techniques actually has cultural currency without having to solve the whole problem and giving you a direction for incremental progress. So that's part of my sort of not so hidden agenda for the work that I do. I guess I still kind of believe in that dream in a way, but sort of in this with this weird twist on it. I do so I haven't really had the problem of finding that by building artwork, I end up not also posing AI research questions. What does come into loggerhead is that building complete experiences, something that's actually, that you can put on the net and download, or that you can, put in a gallery or museum, is a lot of production work that isn't considered research, right? So it's like there's this AI research core, and then this huge amount of production, which is what it really takes to actually move it from some, sort of baling wire and chewing gum thing that you can sort of, turn on for 30 seconds when your sponsors come in the lab and, hope it doesn't crash, to something you can actually disseminate in the wild. And so trying to find ways to do that is what's really hard, I find, and might be related to what you're saying. But on the other hand, I firmly believe that without doing kind of real production, without like actually making an expressive experience, you're not posing the right AI research questions. And I think there's sort of plenty of work as, characters have gotten kind of, sexy as kind of a research area in kind of recent years, and with games, and there's a lot of sort of researchers saying, oh yeah, I'm doing some game-related thing or something. But what I often find in that research is that it's sort of like some simulation in their heads of what an engaging experience might be like, and based on that simulation in their heads of what an engaging experience might be like, then some AI research is done, and then you get this nice little system, but you actually have no idea whether it's any good at all or not in producing an expressive experience. And in fact, I often find when I think about actually using it, well, how would I use that to build, X, Y, or Z art piece? And it's like, oh, guess what? You actually couldn't, right? Because it wasn't asking the right research question to begin with, because they weren't actually, the researcher wasn't actually trying to build a concrete piece of art. So that's why I sort of really believe it's like you've got to do the production work too, but yeah, it's not research for us pre-tenured folk, it's not research. The part of this problem gets solved once you have tenure, right? And you just say, screw it. But I guess then you want full. I don't know. There's always some carrot.
Okay.
Oh, well, you can talk offline if you want.
Yes,
Go ahead, come on up.
Okay.
Thank you.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.